I am presenting my FPGA project implemented on the Edge Spartan 7 FPGA board. The project is a 4-bit up-down hexadecimal counter displayed on a 4-digit 7-segment display using Verilog HDL. This project demonstrates practical FPGA-based digital design including clock division, sequential logic, and display multiplexing. In this project, I used the onboard 50 MHz clock, one switch for reset, one switch for mode selection, the 4-digit 7-segment display for output. The design consists of 4 modules: clock divider, 4-bit up-down counter, hex to 7-segment decoder with multiplexing, top integration module. The top module connects everything together. The Spartan 7 board provides a 50 MHz clock. Since 50 MHz is too fast for visible counting, I designed a clock divider. A 25-bit counter counts up to 2,49,99,999. When the out count reaches this value, the output clock toggles. This produces a 1 Hz clock signal. Mathematically, 50 MHz clock divided by 2 into 25 million equals 1 Hz. This makes the counter update once per second. 4-bit up-down counter. The counter is triggered on the positive edge of divided clock is 4-bit wide, counts from 0 to 15 in hexadecimal. This corresponds to 0 to F operation. Reset is equals to 1, counter becomes 0. Mode is equals to 1, count up. When mode is equals to 0, count down. Since it is 4-bit, after F it wraps to 0. Before 0 it wraps to F. This is synchronous counter because all flip-flops use the same clock signal. 7-segment display multiplexing. The Edge Spartan 7 board includes a 4-digit 7-segment display. Instead of driving all digits at once, I used multiplexing. Multiplexing works by activating one digit at a time, switching very quickly between digits using persistence of vision to appear continuous. The two most significant bits of refresh counter select the active digit. This allows smooth display without flickering. The counter output is converted into 7-segment patterns. The display is common anode type, so logic 0 turns on a segment, logic 1 turns off a segment. The decoder supports full hexadecimal values 0 to 9 and A to F. Simulation verification. In this test bench, I generated a clock signal, applied reset, tested up counting, switched to down counting. Using the monitor command, I verified correct counter behavior in simulation. In this constant file, clock pin is mapped to onboard 50 MHz clock. Reset and mode are mapped to switches. Digit and segment pins are mapped to 7-segment display pins. This connect the Verilog design to actual Spartan 7 hardware pins. On this board, the display updates once per second. It counts from 0 to F. Changing the mode switches reverses counting direction. This project worked successfully on real FPGA hardware. This project demonstrates implementation of a synchronous 4-bit up-down hexadecimal counter on the Edge Spartan 7 FPGA board, including clock division and multiplex 7-segment display interfacing. It successfully integrates sequential logic, combinational recoding, and hardware pin mapping. Thank you.